Okay, so we're in 1.3. Let's see. Yes, 1.3, number 8. So 1.3, number 8 is asking you to do all this, but going back to the directions, it says, for problems 5 through 8, create the missing equation for the sequence based on the table, the description, or the given equation. Then decide which equation will be helpful to find the missing term of the sequence most efficiently. Find the term and then explain your choice. Okay, so here they gave us that the third term is 12. So I don't know if that's helpful to me. So what I'm going to start by is I'm going to write, here's the first term, here's the second term, and here's the third term. Okay, and then in the third term, they said it's 12, so I'll do that. And then it says the sequence is being doubled at each step. So if you recall, double just means multiply by 2. Right? So that means the next guy, I'm just going to multiply 12 by 2. And then I'll get the answer for the fourth term. So 12 times 2, oh, that's 24. And then it would continue, and that would be 48, and so on. So that's my little dot, 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 and so on. Okay. So recursive equation is now equals to previous times 2. I'm going to translate this to math for those of you who are interested in increasingly getting better at writing it in function notation, right? I'll translate that in a second. They want you to find the explicit equation. They want you to find the 10th term, and they want you to explain which one was more helpful in finding the 10th term, recursive or explicit. So, okay, so the next thing I need to do is, okay, so they're doubling it every single time. So I want to go backwards, right? This is what I keep referring back to Noah. Noah said just to go backwards. So how do you go backwards from multiplying by 2? And the right word besides backwards is inverse. How do you undo multiplication? In the chat, very good, thank you, thank you. You would divide by 2. Or if your brain works like this too, you can say what, so here's my what times 2 is going to give me that 12. What times 2 is going to give me my 12. Or if you're going to go backwards this way, you can say 12 divided by 2 gives me my what, right? So either way, you would have figured out, oh, that's 6, Miss Johnson, and you're absolutely right. And so I put a 6 there. Similarly, I would go back and find the first term. So there's 6, and then if I do that again, and I'm going to use divide by 2 because I like the backwards way. So 6 divided by 2 is 3, and that helps me. Done. Okay. So, so because that's that, and I figured out previous times 2, I really quickly want to show you how to write this in terms of math language, right? So if you recall, now is written as f of n. F of n. And we talked about if f of n is now, how would you talk about the previous term? And we use dates, right? So today's the 20th. What was the date of yesterday? And you'd be like, duh, Ms. Johnson, it's the 19th. And I say, yes, that's exactly right. But how did you get from 20 to 19? Oh, we just subtracted 1. Very good. So then previous term should be written as f of n minus 1. And then we just put times 2. So Ms. Johnson, that's it. I just write f of n minus 1 for previous. Yes. And f of n for now. Yes. And so pretty soon I'm going to take this away from you, the ability to write this in terms of words now equals previous times 2, because I want you to be able to write it in terms of math. Because when you do get to integrated 2 and 3, this should be very like, oh yeah, I remember what she was talking about, the previous, next, tomorrow, today kind of thing. Okay, so that's recursive term. Okay, so then the next thing they want me to find is the explicit equation. So for the explicit equation, I could already tell this is not a linear function. This is not a linear function. And so if you don't know why this is a linear function, it's because it's not being added by a constant difference, right? It's not plus 2, plus 2, plus 2, plus 2. we're actually multiplying by 2. And so the way I liked writing this better, and I'm going to try to fit it over here, is I liked writing it as a table, right? So here's my n, here's my f of n. And so the first term I already knew was 3. And my second term was 6. My third term was 12. My fourth term is 24. And my fourth term is 48. And so I asked you guys like, hey, how did I get from 3 to 6? And you're like, oh, just multiply by 2. So instead of writing it like this, I wrote it like this, 3 times 2. Do you guys remember this? 3 times 2. Okay, well, how did you get 12? Oh, hold on, it's not catching up to me. Oop. So the next question I'd ask is, okay, well, how would I rewrite 12? So while my video is loading, instead of writing 6 as 3 times 2, how would I write 12? So here it's 3 times 2. And then instead of writing 12 as 12, I was going to write it as that times 2, right? So let me do that really quick. So then I'm going to use these colors so it shows out a little bit more. Times 2 times 2, right? And then again, instead of writing 24, I'm going to write it as 3. That's right, times 2 times 2 times 2. And you're like, oh my gosh, Ms. Johnson, this is so annoying. I wish there was a faster way to write these 2's. So in the chat, can you tell me if there is a faster way to write these 2's? Is there a faster way to write these 2's? Yeah, exactly, right? You want to use the exponent like piece, right? So you guys do this all the time, right? Like when, think about how you text. Do you text, let's see, when you're laughing at something, do you say, I am laughing so hard right now? No, you don't, right? In the chat, tell me what you text instead of writing, I am laughing so hard right now. Oh, is that what you do? Oh my gosh, that's funny. Okay. Exactly. You guys have a shortcut. It's called LOL or LMAO or LOROFL or all those other shortcuts. So literally we will write these as a shortcut, and our shortcut here is going to be like some version of exponent. So here, let me scooch you over. So if you notice that 3 still exists over and over again, so that's going to be 3 times, 3 times, 3 times, 3 times. And then I have this 2, right? I have these 2's, and then I have my exponent. So this one's 2 to the first. The second one is 2 squared, 2 third. I hope this one's 2 to the fourth. And it looks like it is, right? It's 3 times. And then I got the 3 from earlier. And then I got my extra one. So yeah, that works, right? So then I'm almost done writing my explicit term, except for if I go down here, did I really write 4, 4? Look at me and my writing. 1, 2, 3, 4, 4. I know how to count, you guys. I promise. Most days. Some days. Maybe not Tuesdays. Just kidding. So 6 all the way down to n. Okay. So how would I write the nth term? So the nth term, I'm going to scoot all the way over here. I already know that 3 is going to be there. I already know that 2 is going to be there. But my problem is I don't know what my exponent is. So really what I want you to be focusing on is this. Where the heck did I get this exponent? Where did the 4, the 3, the 2, and the 1 go? I'm hoping it's based on my n. Because if it's based on my n, I'm good. So, does anybody see a pattern between n and the exponent? N and the exponent? Could you write it in the chat? What do you see in the exponent? The pattern between 5 and 4. 4 and 3. 3 and 2. And 2 and 1. What? Yes, exactly. Okay, thank you so much for putting that. Yes, the exponent goes up by 1. Are you sure, Ricky? Does it go up by 1, 5, and then it goes to 4? Or do you mean down by 1? Yeah. I got you. So yes, it's down by 1. So the way I would write down by 1, as Ricky has put down by 1, right? I would take my n and make it go down by 1. Looks like this, n minus 1. Minus 1. You will notice that whenever you get this multiply by 2, multiply by 2, multiply by 2, we will always have this structure where you see this 3 times, and then you'll have this base, and then you'll have this exponent up here. And then you just have to play around with your numbers to figure out what goes in each one. Does that make sense? And that's something that you'll start noticing. Like, you should already know where this 3 comes from based on our terms here. You should know where this 2 came from based on how it moved, right? How it grew. And now with the way Ricky explained, you now know where this exponent came from. It's down 1 from your n. Okay, so that goes right there in my explicit function. So I'm going to copy that really quick. So the big deal here, whenever you're, where did that go? Here. The big deal whenever you're writing a function is always going to be this, for me anyway. Do you know where each of those numbers came from? Do you know where the 3 came from? Or is that like 3 is her favorite number? Do you know where 2 came from? Or is like, she's always going to put a 2 there? Do you know where the n minus 1 comes from? If you say yes, yes, yes to all of these, then you can write these over and over again. The only thing that's going to change is where we start from or stuff like that. Does that make sense? Okay. I did realize that now that I look at my recursive function, I forgot one piece. The first piece of your recursive function is supposed to be your starting point. So I need to write that down here. So my starting point here is going to be f of 1 is 3. F of 1 is 3. Okay, so now, okay, I did my recursive. Check, I did my explicit. So go over these in your head to make sure that it makes sense before we move over to the 10th term. Okay, so the next question is find the value of the 10th term. Okay, so my choices are either recursive or explicit. Recursive says just multiply by 2 to get to the 10th term. Well, that's going to be like far, I mean, that's not too bad because look, if in order to find the 10th term, I need the 9th term. And then in order to find the 9th term, I need the 8th term, the 7th term, the 6th term, and then I can find it. So the recursive formula is not too bad here, but imagine if I asked you for the 50th term, right? The 50th term, that would be like, what? Okay, to find the 10th term, I'm going to opt to use explicit. Okay, I'm going to opt to use the explicit form. Now, if you don't understand why the explicit term, then use the recursive term and see why it would be that. So here I go. F of 10 is equal to, I'm plugging it into this equation here, 3 times 2 to the 10 minus 1. Okay. And then, so again, you can use your handy dandy calculator. You can use Desmos. You can use a lot of different methods. I'm going to be using Desmos because that's my favorite. And so here, and I'm going to plug that in exactly as I see it. So 3 times 2 to the, and that's a little arrow in case you don't know, it's a shift 6 to the n minus 1. In this case, it's 10 minus, oh no, the minus went down. I don't want that. I want to go up here. So I'm going to hit minus. Oh, it's still not doing it. So what I'll do is I'll put parentheses to say, stay up here. Stay up here. Okay. And that, see how this looks like this? That's why I like Desmos, by the way, because it looks like how I wrote it, right? So then I'm going to write my answer. My answer is 1,536. Put a little box around that. So that's my 10th term. Okay. Now, for me, why did I choose to use the 10th, the explicit? And I'll just type this out really quick because I can type faster than I can write. Okay. So the reason why, let me just make this a tad bigger and then highlight it so it stands out. Okay, so the reason why, oops. Oh man. The reason why I chose explicit is because I could just plug in and simplify the expression. If I used the recursive, then I would have had to find all of the previous terms. 9th, 8th, 7th, and so on. Okay. There you go. Okay. So that is done. Okay. The next thing that we're going to work on